Hello everyone, this is Ayush Tandon and I have come back with a new problem of mathematics. So the problem goes something like this. So if x is equal to x by 2 plus x plus 1 by 2 and these square brackets denote greatest integer function. So you have to show that n plus 1 by 2, the greatest integer function of this, n plus 2 by 4, n plus 4 by 8, n plus 8 by 16 and so on is equal to n, where n is an integer. You can give this problem a try and then after you have solved you can just look for the solution. So here I begin. So if this property is given to us, so most likely we have to use this property to get on to this result. So let me insert x is equal to n because it is true for every x as per the question. Now let me insert x is equal to n. So what I will get? N by 2 plus n plus 1 by 2, and you should notice that n plus 1 by 2 is one of the terms in the question, so we can just find n plus 1 by 2 is equal to greatest integer function of n plus minus n by 2. Now the trick is how to get n plus 2 by 4 and the rest of the other terms. So you can just see, if you see the pattern, you may think it's something 2 to the power r pattern. Well, certainly yes, you can say, but if you insert x is equal to n by 2, so you put x is equal to n by 2, so greatest integer function of n by 2 is n by 2, the half of this, plus n by 2 plus 1 by 2. So what you get? You get n by 2 is equal to n by 4 plus n plus 2 by 4. Yes, so you get this. Now this is one term of the question, so we can find out this as a function of n by 2 and n by 4. So if we write, so we get n by 2 minus n by 4 is nothing but n plus 2 by 4. And similarly, if you calculate n plus 8 by 4, or what, n plus 4 by 8, sorry, so you will get n by 4 minus n by 8. So if you sum up all these, so if you add these all, so basically this is the required sum which I write it as s. So very clearly you can see that what we will have to do. So let me write it in a clean way. So you will get n minus n by 2 plus n by 2 minus n by 4 plus n by 4 minus n by 8, and this n by 8 minus n by 16, and this will go on. So for infinity, if you see n by infinity something, this is relatively, you can say, 0. So, and very clearly you can see that n by 2 and n by 2, n by 4, n by 4, these are getting cancelled. So the term with which you are left, let me switch the page. So the term with which you are left is s is equal to n, and in the question it's mentioned n belongs to integer. For any integer n, greatest integer function of n is the only function. So s is equal to n. This is how you prove. So hence proved. So I hope you like this problem and like the video and subscribe to my channel. Till then, bye.